You have a seesaw made of a plank of mass 10 kilograms, length 3 meter. It's balanced on a fulcrum 1 meter from one end of the plank, and a 20 kilogram mass rests on the end of the plank near the fulcrum. What mass must be on the other end? Okay, so that's the plank, and you have the fulcrum 1 meter away, so that's where the fulcrum is. And so you have the 20 kilograms at one end and 30 at the other end, and the total length is 3 meters. What mass must be kept at the other end? Okay, so you're looking for this mass. And a 1.5 meter, which is the center of the plank, is the point through which its mass is acting. And its mass is 10 kilograms, right? And that's the fulcrum. So when you calculate the torque, you're going to see that there are two clockwise. That's one, and this is the second. Both of them together should add up to the torque created by the 20. Now what is the torque of this? It will be m times this distance, which is going to be 2 meters, and plus 10 times this distance, because this is 1.5 and this is 1, this distance is 0.5, right? So again, m times 2 plus 10 times 0.5 should be equal to 20 times 1. So that's where we're taking the torque. 1 counterclockwise, 2 clockwise. Solve that and get the mass as 7.5 kilogram. Okay, and here in this question you have a 30 kilogram child at one end and a 40 kilogram child at the other end. And it says the fulcrum is 1.10 meter from the 30 kilogram child. So that's clearly mentioned here, 1.10 meter. That's the fulcrum. And what you don't see is the mass of 20 kilograms acting right through its center. Okay, so let me put that down. Its mass acting right through the center. So there you go. That's the situation there. So when you calculate the torque, you have one clockwise, which is this, because it's trying to rotate it this way, and that will be 30 times 1.10 should be equal to 20 times this distance plus 40 times this distance. You see? So that's going to be, yeah, we're trying to find the length, so let's take it as L there. So 40 times L minus 1.10, because that's this distance, plus 20 times L by 2 minus 1.10, because this is at the center. So you know that this is half of it minus 1.10, because this is L by 2. This much is L by 2, right? So this distance would be L by 2 minus 1.10. Okay, and then do the math. Distribute the 40 there, rearrange, be careful, calculate the length. Get it as 1.98 meter. Now we come to the ladder question, which I tried to explain in class. Okay, so the length of the ladder is 5 meters and it's kept 3 meters away, so this must be 4 meters. Okay, and what you see now are the forces. The weight of the ladder acting right through the center down the weight of the man standing there, again acting vertically down, and actually you're trying to find out this distance x. So how far away can he climb, you know? And then this is the friction force at this point, and then you have the normal reactions at the two. So normal reaction here and normal reaction at the floor. So what you got to understand is that the forces along the x must cancel out, and there are only two forces along the x. One is the friction, the other is this normal force. They must be equal to each other. And in the same manner, this force acting up must be equal to the sum of these two. So both along the x and the y, the forces must cancel out. Now, since we know these two, you can add them up and you will get this normal force. Okay, so that's 5, 3, and 4. Those are the names that I've given. This is 117.6 and this is 588 newtons. Okay, so the normal force Fn1 is the sum of 117.6 and 588, which gives 705, and friction is mu times Fn, and the coefficient is given as 0.28, so times 705.6 and you get friction. Since you know that this frictional force must be equal to this, so you also know Fn2 now. And then what remains is you have to calculate the torque about this point. The reason being then Fn1 and friction both do not have a torque here because the distance is 0. So you're left with one counterclockwise, which is this times, watch this carefully, this times the perpendicular distance between the line of action and the point, which would be this much. That is 4 meters, isn't it? Okay. So this times this. You're measuring all distances from this point. That's the counterclockwise. And the clockwise would be 117.6 times the perpendicular distance, which is this much, plus 588 times the perpendicular distance, which is this much. Alright, so whatever you call it, that is the idea. So there are two clockwise and one counterclockwise. So therefore Fn2 times 4 is equal to 588 times, and we do not know these distances, but you know we can find this angle first. So if you call this angle theta, you can find sine theta, because sine theta is opposite by hypotenuse, so 4 by 5, which gives you 0.8. From that you can find the angle. So let me call this x, and this is x1, call this distance x2. So theta is 53.13 degrees. I'm trying to find x1 and x2. Okay. Cos theta gives you x2 by 2.5 because surely this will be half. So cos theta is this adjacent divided by hypotenuse, from which I get x2 as 1.5. Well, you could have really got it straight away, because if this is halfway, then surely it should be halfway here too. Anyway, and similarly you can find out the other distance. Okay, so when you plug it back into this, you get the value of x1. Now again, go for this big triangle here, from which again cos theta is x1 by x, and since we got x1 as 1.044, it's just a matter of substituting there. and you get the value of x as 1.7 meter, and this is an important question. And then you have this truck carrying a 120 kilogram refrigerator, 2.2 meter tall, 85 centimeters wide, and saying what's the maximum acceleration that the truck can have before the refrigerator begins to tip over. If the truck accelerates, then the refrigerator has a tendency of tipping over this side, right? Okay, so now we got to think about what are the torques that are keeping it there. So, well, that's what happens when it tilts over, but you really don't need that. So let me just look at the forces. This force is created by the acceleration of the truck, and that's going to create a torque at this point, because that's obviously where it's going to tip over, right, at that corner. And what would that be? That would be force multiplied by this distance. And what's trying to keep it there would be the weight, which is this force, mg, times this distance. So the only thing you need to know is F times 1.1, which is half of the height, should be equal to mg times half of this, which is 0.425 in meters. And when you calculate that, mass is 120, g is 9.8, substitute that and you get the answer. 454.36 newtons. And once you have the force, you can find the acceleration, because acceleration is force by mass. The mass is 120, so 3.79 meter per second squared. That's the maximum acceleration that this can have. Number 7, we had already done in class, but look at the leaning tower and look at the geometry of that. Well, I really want to put a picture of the tower. But this in itself will make you understand that the vertical line drawn from there is making a certain angle with the axis of the tower, and let's call that theta. And so tan theta would be 4.5, which is given. It's 4.5 meters off, and that would be 4.5 meters off. Tan is opposite side by adjacent side, so 4.5 by 55, and from which you can find theta. And tan theta maximum can be found out by drawing a vertical line from the center, because that's the point through which the weight is acting, right down. So, and then you see that, that you have two similar triangles. You see this little triangle here, which means that angle should be the same as before, but now we can give that as x. So we can say that is x divided by this, which is half, right? So x divided by half of 55, which is 27.5. So from that you get x is, let me write that again. I wanted to write this in one step now, instead of making it two steps. So treat it like a ratio. And from which you can get x as 2.25 meter. So if the center can move so where do I get that 1.25 from? Because it's already 4.5 meter off, right? Because the diameter is the radius is 3.5, so 3.5 minus how much more it can move. Okay, gives you 3.5 minus 2.25, which is 1.25. So if the base, if the center can move 1.25 meter, that means the top can move double that, which is 2.5 meter. Takes a little thinking. And then you have a 25 kilogram wooden sign, 3 meter by 2.2 meters, and it is supported by 2 nails at this point and at this point. All right, okay. And you're asked to find the horizontal component of the force on the top nail, on this one. So now you see the two forces here. This is the weight acting right through the center, and this is the horizontal component of the force here. And you can see when you take the torque at this point, this force creates how much? Force times this distance, and that's clockwise. And the counterclockwise would be this force multiplied by, we're taking it here, you're calculating the torque here, of course. So it'll be this force multiplied by this. Let me try that again. You're calculating the torque at this point. Therefore, the clockwise is this force times this, and the counterclockwise is this force times this. And so if you call it X and Y, you have the counterclockwise F times Y, and the clockwise is mg times X. Calculating the torque at that point. And so you can calculate the force, because the mass is 25, G is 9.8, X is half of 3, which is 1.5, and Y is 2.2. And you get the answer as 170 newtons. In the ninth one, it's again a direct Young's modulus question. The elastic modulus is given. You have to find out how much it stretches, and you apply the formula directly. The force here is 1000. Of course, make extension the subject and plug in all the others. Force is 1000. The area of cross section is given in millimeter squared, and you've got to be careful when you change millimeter squared into meter squared. You're going to get 10 raised to minus 6. So you get 1 meter. That's how much it extends. In the 10th one, you have a meter stick that balances at the 50 centimeter mark. That means its center of mass is acting exactly at 50 centimeters. And then you have a mass of 50 gram placed at the 90 centimeter mark, right there, 50 gram. And now the stick balances at 61.3. So again, here you have a clockwise and a counterclockwise, and they must be equal to each other. Clockwise is, counterclockwise is m times this distance, right? Should be equal to 50 times this distance. And you get the mass of the meter stick as 127 grams. Number 11, you have 3 meter long plank. Negligible mass has 30 kilograms at one end and 40 kilograms at the other. And how far from the 30 kilogram mass should a fulcrum be placed? So let's assume that the fulcrum is x meters. Therefore, this distance is 3 minus x. You only have two torques. One is clockwise, which is 40 times 3 minus x is equal to 30 times x. That's all. Just solve it, you get the answer. So 1.71 meter. That brings us to the last one. What is the maximum length of a steel cable that can be supported? Young's modulus is given the tensile strength. If you look at the unit, you understand that's the maximum strength that the material can take before it snaps, before it breaks. And so that is F by A. Tensile strength is F by A. So 7.4 times 10 to the 8. That's given. And density is mass divided by volume. Yet volume is area times the length. Rearrange that, you would get the expression for mass. And now you know that the force is actually the weight of the cable itself, which is mg. So mg by A is equal to this. So substitute for mass, the A's get cancelled, and that is equal to 7.4 times 10 to the 8. Now rearrange all that and make the length the subject. So you got to divide by the density, and then times 9.8. When you do that, you get it as 9.93 times 10 to the 3 meters, which is 9.93 kilometers. Well, steel is strong, so that much can be supported before it snaps. And this is done under 25 minutes, and I hope you really understood. Good luck.